Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Power supply unit issues are among the most critical and potentially overlooked problems in system diagnostics. Because the power supply affects every component in the system, failures can present as a wide range of symptoms, from complete power loss to random reboots, fan malfunctions, or unexplained instability. A malfunctioning PSU may not leave behind clear error messages, but it often serves as the root cause behind intermittent crashes, boot failures, and system noise. Diagnosing and resolving power supply problems is a fundamental skill for A+ technicians and a topic frequently tested on the exam. Complete power failure is one of the most obvious PSU-related symptoms. In this scenario, the system shows no signs of life. No fans spin, no lights turn on, and pressing the power button produces no effect. While the power button itself could be disconnected or defective, the more common culprits include a failed power supply, a dead motherboard, or a loose internal cable. This condition should trigger an immediate inspection of external connections, followed by a step-by-step verification of internal power delivery. Verifying PSU output involves testing the voltages on the unit's primary rails, 12 volts, 5 volts, and 3.3 volts. This is typically done using a dedicated PSU tester, which connects to the 24-pin ATX power connector and displays the voltage levels. A multimeter can also be used for more precise readings, though it requires familiarity with the correct pinout. If any of the voltages are missing, below tolerance, or fluctuating, the PSU is not delivering stable power and should be replaced immediately to prevent damage to other components. Intermittent power loss or reboot loops often point to a PSU that is unstable under load. These issues may appear as the system rebooting during startup, shutting down while launching applications, or crashing during demanding tasks like gaming or video rendering. Loose connectors, deteriorating capacitors, or thermal issues inside the PSU can cause voltage drops or erratic behavior. Motherboard short circuits can also lead to reboot loops, but it's critical to rule out the PSU first before investigating deeper. An overloaded or underpowered PSU can also manifest as instability. If the PSU wattage rating is too low for the system's total demand, especially when high-power components like graphics cards or CPUs are under load, the system may reset or fail to boot entirely. This often happens when a powerful GPU is added to a system that was originally built with only integrated graphics. To prevent such issues, it is important to ensure the PSU can handle peak loads and still maintain voltage stability across all rails. Calculating the required power for a system should always begin with a detailed analysis of the components involved. Online PSU calculators allow technicians to input the CPU, GPU, number of drives, fans, and other hardware to estimate the required wattage. It is best practice to add additional headroom, typically 20% or more, to account for future upgrades and unexpected power spikes. Efficiency ratings also come into play, as a lower efficiency unit may draw more power from the wall while delivering less to the system. Unusual noises coming from the PSU, such as whining, grinding, or excessive fan noise, are often warning signs of imminent failure. A clicking fan, or one that fails to spin up at all, can lead to thermal buildup and internal damage. A fan replacement might be possible for some models, but this usually voids the warranty. In general, a noisy PSU should be replaced, as continued operation risks permanent damage to both the unit and the components it powers. Surge protectors and uninterruptible power supplies are essential tools for preserving PSU health. Surge protectors guard against voltage spikes that can damage internal PSU components. A quality unit will also include line conditioning to smooth out power fluctuations. UPS devices add another layer of protection by preventing unexpected shutdowns during outages and allowing systems to shut down safely. These devices must be rated for the system's power draw, including all connected peripherals, to provide meaningful protection. Unprotected power sources pose a significant risk to both the PSU and the motherboard. Lightning strikes, brownouts, and overloaded circuits can destroy components instantly or cause cumulative damage over time. Systems should never be plugged into daisy-chained power strips or ungrounded outlets. Instead, they should be connected to a grounded surge suppressor or, ideally, a UPS with AVR or automatic voltage regulation. These devices help stabilize power delivery and extend the lifespan of sensitive internal hardware. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Testing a system with a known good power supply is a reliable method to confirm whether the original PSU is at fault. If a PSU tester or multimeter is unavailable, swapping in a functioning unit with sufficient wattage and the correct connectors can verify power-related issues quickly. Before doing so, always power down the system completely, unplug the original PSU, and discharge any static electricity. Connecting a known good PSU and observing whether the system boots normally helps rule out or confirm the original power supply as the root cause. Understanding how PSU connectors are keyed is vital for avoiding incorrect installations. The 24-pin ATX connector powers the motherboard, while 8-pin CPU connectors deliver power to the processor. SATA power connectors, supply drives, and Molecs may be used for legacy devices. PCIe connectors power graphics cards. Each connector has a unique shape or latch that prevents improper insertion. Technicians must double-check orientation, labeling, and pin alignment before connecting power cables. Forcing the wrong connector can result in damaged pins or even a short circuit. Visible damage to PSU cables is a clear sign of danger and impending failure. Melted insulation, frayed wires, or connectors that appear burnt or discolored indicate overheating or arcing. Systems powered by such PSUs may spark at startup, shut down suddenly, or produce a burning smell. Power cables should never be patched or repaired. If there is any evidence of cable damage, the entire PSU must be replaced immediately. Reusing damaged power equipment puts the motherboard and all connected components at risk. The difference between modular and non-modular PSU designs also plays a role in installation and maintenance. Modular PSUs allow technicians to connect only the cables needed, improving airflow and simplifying cable management. Non-modular units have all cables permanently attached, which can lead to clutter inside the case. One critical point is that cables from one modular PSU model are not guaranteed to work with another model or brand. Using mismatched cables can short out devices or fry the motherboard. Always use the original cables that came with the PSU. Some modern power supplies use a 0 RPM mode in which the fan stays off when system load is low and temperatures are within a safe range. While this improves energy efficiency and reduces noise, users may mistake it for a fan failure. Before replacing a PSU based on a silent fan, review the manufacturer's specifications. Many high-end units include software or indicators that show when the fan is intentionally idle. Misinterpreting normal behavior can lead to unnecessary replacements. Power supply failures often mimic problems associated with other components. For example, a failing PSU may result in graphical artifacts that resemble GPU errors, or it may cause random system shutdowns that suggest faulty RAM. In systems with multiple symptoms or irregular behavior, the PSU should always be tested early in the diagnostic process. Its central role in powering every component makes it a likely suspect in complex failure scenarios. Ignoring the PSU can lead to misdiagnosis and wasted effort replacing good hardware. Efficiency ratings are another consideration when selecting or evaluating a PSU. The 80+ certification program rates power supplies based on how efficiently they convert power from the wall to usable energy. Bronze, silver, gold, platinum, and titanium reflect increasing levels of efficiency, with higher ratings indicating less power loss and lower heat output. An efficient PSU consumes less energy, runs cooler, and typically lasts longer. For business or high-performance systems, investing in a higher efficiency PSU can reduce both electricity costs and thermal stress on internal components. Manufacturers often support their PSUs through extended warranties, some lasting 5 years or more. When a PSU fails, initiating an RMA return merchandise authorization requires providing the serial number, a description of the symptoms, and proof of purchase. Some vendors offer pre-approval tools or automatic validation based on serial codes. In many cases, the manufacturer will provide a replacement unit or offer credit toward a newer model. Keeping documentation of installation dates and system specifications speeds up the warranty process and ensures eligibility. A common example of diagnosing a power supply issue might go like this. A user reports that their system powers off while gaming and automatically reboots. The technician uses a PSU tester and discovers that the 12 volts rail dips significantly under simulated load. This voltage drop leads to instability in the CPU or GPU during high demand. After confirming the symptoms with a known good PSU, the technician replaces the unit with a higher rated power supply. The problem no longer occurs, and the system remains stable under full load. Documentation is completed, and the issue is resolved. To summarize, power supply problems can take many forms, from no boot conditions to subtle instability during system use. Verifying output, checking cables, ensuring proper wattage, and watching for unusual sounds are all part of a complete diagnostic process. Surge protection and battery backups help protect PSUs from environmental threats, while proper installation and maintenance practices extend their service life. When in doubt, test with a known good unit and never underestimate the impact a faulty power supply can have on system behavior. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.